Hi everybody, so today we are talking about volume of three-dimensional shapes. So take a moment and think about what you know about volume and how does it compare to area. So as you can see on the screen, the volume of a solid is the number of cubic units that the solid contains. So when we have a flat shape, we usually calculate area to figure out how much space the shape is occupying. But when we have a three-dimensional shape, because we have length, width, and height, area is no longer for the inside. We could do surface area, which would be the outside of the shape, but volume is how much space we could fit inside of the shape. So let's take a look. Very important. The general formula for solids is V equals capital B times H. Capital B stands for the area of the base. So if you think about it, what we're calculating is the area of the bottom of the shape, and then we're multiplying it by how tall it is. So think of it as stacking a bunch of the bases on top of each other, and that's what volume is. So you're always calculating the area of the base first, and then multiplying it by the height. Don't get confused and think the formula is just base times height. That would be a lowercase b. So again, capital B stands for the area of the base. So I'm going to show you three different examples where we're going to calculate the volume, and we're going to use the same formula. It's just going to modify depending on the shape that the base is. So first is our cylinder. So again, we're going to use V equals capital B times H. Now, the base of a cylinder is a circle. The area of a circle is pi r squared. So really this formula is pi r squared times H. Now they told us the radius is 4 and the height is 8, and we'll leave the answer in terms of pi for now. So we get pi times 4 squared times 8. 4 squared is 16. 16 times 8 is 128. So this is going to be equal to 128 pi inches cubed. Because it's three-dimensional, length, width, and height are being incorporated, our answer should always have a cubed on it. Take a look at the next one. Now, if you notice, they didn't give me the width, right? They gave me the length of the box and the height of the box. And then for some reason, they gave us this diagonal. So think for a moment, how could I use that diagonal to get the height of the box? So hopefully you realize that this diagonal creates a right triangle. So using the length as 24, and the diagonal as 26, I can find the width of the box, and then that will allow me to find the volume. So really quickly, I'm going to have to use Pythagorean theorem there. So 24 squared plus x squared equals 26 squared. Again, the diagonal is the hypotenuse, so make sure that's C. 24 to the second power is 576. 26 to the second power is 676. Subtract. We get x squared is 100. Square root x equals 10. So my width is 10. So now I can find the volume. Now again, volume is area of the base times height. Now this base is a rectangle, which is length times width. That's why I needed that width. So this is going to be 24 times 10, which is 240. And then my volume is that times the height, which is 10. And 240 times 10 is 2,400. And again, centimeters cubed. Okay, again, cubed because it's three-dimensional. Last one here. So take a moment. What shape is my base here? And hopefully you remember that formula. So the area of this base is, first of all, the shape of the base is a trapezoid. Okay, so I need to figure out what the area of the trapezoid is. So hopefully you know that formula. It's base 1 plus base 2 divided by 2 times height. So let's calculate that first. So that's going to be 12 plus 8 divided by 2 times 6. So 12 plus 8 divided by 2 is 10 times 6 is 60. Now we'll calculate the volume, which is area of the base times height, and the height is 20. That's what that 20 is representing. So it's 60 times 20, which is 1,200. They didn't give us units, so we'll just say, we'll call it inches. Why not? Inches cubed. So there was 3 examples of finding the volume of solids. Again, remember this formula where capital B is the area of the base. Before we continue, we're going to talk about something very briefly called Cavaliere's principle. So the main idea of Cavaliere's principle kind of relates to the idea of like a stack of quarters, or even like a Rubik's Cube, which is like a stack of squares, right? Now, that shape, if you look on the right here of our quarters, has a particular volume. The stack next to it is the same number of quarters. If I push the quarters so they're no longer in a perfect straight thing, do you think the volume changed? So pause for a second. Did my volume change when I pushed my little stack of quarters? So hopefully you understand that no, my volume didn't change. I just changed the way the shape looks. That's what Cavaliere's principle says. You can lean the shape, the volume doesn't change, okay? As long as the area that it takes up stays the same, they will have equal volume. Same with the Rubik's Cube. When you twist the Rubik's Cube, you're not changing the volume, the space that it takes up, you're just making it look different. So that's what Cavaliere's principle is. And this kind of relates to the idea of an oblique cylinder, right? Find the volume to the nearest integer of this oblique cylinder. And again, it's the same as finding the volume of a regular cylinder. All you need to know is the area of the base times the height. So let's see. They told us the radius is 2 and the height is 7. See, they said slant height. So that's going to be a little bit different when they say slant height. So let's talk about that for a second. So slant height is this side here, okay? So that's what's 7. Really, it should have units. We'll say inches, right? 7 inches. So the slant height is 7. Obviously, to find the volume, I need the regular height, which is here. Okay? Now, they told us it makes a 45-degree angle with the flat table. So I'm going to have to use our last unit of trig to find this height. So take a moment, try to recall, how am I going to find that height? Which trig function do I need to use? So hopefully you realize that this is the opposite side and this is the hypotenuse, so I'm using sine. So sine of 45 equals x over 7. To get x alone, we're going to multiply by 7 on both sides, and then we multiply. Make sure your calculator's in degree mode. 7 times the sine of 45 gives us 4.9497. So we'll say approximately 5 inches, okay? Now I can calculate my volume. So remember, volume is capital B, which is area of the base, times height, which is pi r squared times height. So pi times the radius, which was 2 squared, times the height we just found, which is 5. Remember, we're not using the slant height. I need the height of the actual shape. The slant height just helped us get the regular height. This is going to be pi times 4 times 5, which is approximately 20 pi inches cubed. Now, if I wanted to find the answer, not in terms of pi, I would just multiply the 20 times pi in my calculator. Obviously, you're going to get a crazy answer because pi is irrational, but we'll round it. We'll say approximately 62.83 inches cubed. And that's just taking the 20 times the pi and putting it in my calculator. We're going to skip this, think about it, but you guys can totally read this on your own time and see what you think about it. Maybe your teachers will have time to cover it in class, but I want to keep this video short, so we're going to keep it moving. We have a couple more shapes to talk about. One is a pyramid. So a pyramid, obviously, if you think of like Egypt times, right? I'm sure you learned about it in history. It meets at a point. All the sides meet at a point. So the volume is definitely going to be smaller than that of a solid, right? Or a prism is what we call them, not solids, prisms, because it's not going straight up all the sides. They're meeting at a point. So to incorporate for that, we have to just multiply the formula by 1/3. But the rest of the formula is still the same. It's still area of the base times height, just times 1/3. So let's take a look at a quick example. Find the volume of a rectangular pyramid. So rectangular is telling me the shape of the base with a length of 4, a width of 6, and a height of 8 to the nearest 10th. So again, 1/3 area of the base times height. Well, the area of a rectangle is length times width times height. 1/3 times 4 times 6 times 8. So again, it's very similar to the prisms we were doing on the previous slide. I just need to now multiply by 1/3, again, because the sides aren't going straight up, they're meeting at a point. So we're going to take up less space. And we actually get a nice answer here of 64 centimeters cubed. Again, it's still cubed because it's still volume. So that's an example of a pyramid. Now here's a cone. Cones and pyramids actually have the exact same formula, 1/3 area of the base times height. And again, capital B is area of the base. What shape is the base of a cone? So hopefully you said circle. All cones will have circular bases. So this formula is going to be 1/3 pi r squared times h. Kind of similar to a cylinder, except again, we have to incorporate this idea of 1/3. So take a moment, try to give this example a shot, plug in, get your answer in terms of pi, and then you can multiply by pi to get your answer to the nearest 10th. So let's quickly plug in 1/3 times pi times 3 squared times 8. Okay, so I'll leave it in terms of pi first. So 3 squared is 9 times 8 times 1/3. Gives us 24 pi, and now I'm going to put that in my calculator to get an approximate answer of 75.4. Did they give me units? Yes, inches cubed. Okay, so again, how did I get the 75.4? I just put 24 times pi in my calculator. Okay, couple more shapes to go, 2 more examples. The first is a sphere. So a sphere is kind of like a globe, right? It's a circle, but like a 3-dimensional circle. It has its own formula, and that's 4/3 pi r cubed, okay? So let's find the volume of the globe that has a diameter of 10 in terms of pi. So they want me to leave pi in my answer. What is the relationship? First of all, diameter spelled wrong. My apologies, that's a typo. What is the relationship between diameter and radius? So hopefully you realize diameter is double a radius. So if the diameter is 10, the radius is 5. That's the only dimension I need for this formula. Times 5 cubed. It's cubed again because I need 3 dimensions. And the only thing I'm using in a sphere is radius. So it's radius to the 3rd power. So that's 125 times 4/3. And that gives me 166.667 pi. I'm going to just put that into a fraction in my calculator, and that's 500/3 pi inches cubed. And again, if I wanted to find it to the nearest 10th, I would just multiply by pi. Last example here. Why don't you guys pause the video, read it, and see if you can think about how you would find the volume of this entire composite shape. So a composite shape is nothing more than a shape that's made up of other shapes, right? So if I want to find the volume, hopefully you realize I have to find the volume of the individual shapes and then add them up. So it helps if I know what I'm dealing with. So the shape on the left here, right, that looks like a prism, a rectangular prism. The shape on the right is a square or also a rectangular prism, right? And then what's the middle shape? Well, they kind of told you. It's a cylinder, which is also the same formula as the prism. So all 3 of these shapes have the formula area of the base times height. All that's going to change is what shape the base is. So let's do each shape individually, and then we'll add them all together. So again, take a moment, pause, give it a shot, and then replay the video to see if you got it right. So the shape on the left is going to be length times width times height. The shape on the right is also going to be length times width times height. And the shape in the middle is going to be pi r squared times height. Okay. Now the length, width, and height are labeled pretty nicely on the prism, and they gave us the length, which is going to be the height of the prism. I know it seems kind of weird that that's height, but again, it's how many times you're stacking the base. So that is your height, the 3.5. And if your diameter is 0.5, the radius, what is the radius? Again, it's half of that, or 0.25. Okay, or a quarter. So let's plug everything in. So let's do the prism on the left first. This is 1.5 times 0.5. Why'd I use an x for times? I never use an x for times. Times 0.5, sorry about that, times 2.5. And we get 1.875. Change the colors just so you can see the difference for the middle shape. Pi times 0.25 squared times 3.5. And it said to the nearest hundredth, so I am going to have to multiply by pi. I'm going to leave it in terms of pi just for now. I'll do it at the end. And then my shape on the right is 2.5 times 2.5 times 2.5, or 2.5 cubed. And that's 15.625. And again, I have to add these three things together. So at this point, I'm just going to multiply this in my calculator. 0.21875 times pi. You should get a number that's approximately 0.68722. You don't want to cut the decimals too early because you want to round at the end. And now I'm going to add up that with the other numbers, 1.875 and 15.625. Final answer should be approximately 18.18722. And they said nearest hundredth. Hundredth is the second place. The 7 means it's going to round up, so I should get 18.19 meters cubed. So that's really it for volume. Obviously we can use more practice, but we'll get to do that later in the week. This is just a nice video to see all the different shapes that are out there and how to find the volume of them. Thank you again for watching.